In this example, which looks a lot like one of your homework problems, we're going to take this data table from an experiment with a completely randomized design. I'm going to show you through the series of two videos, one, how to complete an ANOVA table and test a hypothesis using your TI-84, and the second will be to do the same thing using Excel. And what we want to do here, our ultimate goal, is to take a look at this experiment and test if the three means are equal. The alternative hypothesis would be that one of them is different. We're using a significance level of 0.01. So the first video here, we're going to use a TI-84, which is right here. And I went ahead and entered, hang on here. I went ahead and entered the data into lists 1, 2, and 3. So the data from the table is already entered into these three lists. To do an ANOVA analysis, and if you've read the notes, you see how long and how many pages it took to show how to do it by hand. It's not complicated math, it's just time consuming. I'm going to choose ANOVA. I've got three lists I'm working with. The comma is important here. So list 1, comma, list 2, comma, list 3, close the parentheses, hit enter, and here we go. It's given us our F number, our F statistic, our p-value, and right here we're using a significance level of 0.01. We can see here that that p-value is greater than that. I already know that I'm not going to reject the null hypothesis because the p-value is greater than my critical value. But we'll go ahead and go down through this. The degrees of freedom is 2, and then we've got our factor information, we have our error information, and you can fill out the ANOVA table using this data right here. So if I went down using this data, you can see all of our information is right here. So we've got, I'm getting stuck here, guys. Funny, I rolled over my headset. So treatments here, degrees of freedom is 2. For the error, it's 9. Total of 11. Our SS number, 12.301. For the error, it's 13.928 for a total of 26.229. MS for treatments is 6.151. For the error is 1.548. And then I need to move my calculator. And for the F statistic, 3.974. So as you can see, if you follow with your calculator, the F statistic of 3.974, the p-value, I did not get in the table. So we've got degrees of freedom is 2. The SS for the factor is 12.301. The MS is 6.151. Error, we got degrees of freedom of 9, 13.928, 1.548. And there you go. So this would answer that table. Again, to test the hypothesis that the means are equal, we would look at the test statistic, and we could use the tables in the back of the book to look at our critical value, or even more simply, look at this p-value. This p-value right here is greater than our significance level of 0.01, which means that it does not lie in that critical region. If I were to draw that, we've got our significance value of 0.01, and we've got a p-value of 0.05. It does not fall in this region, so we fail to reject that the means are the same. Okay, the next video will show you how to do the same thing in Excel.